interactive JavaScript panel. We're going to talk about JavaScript today. These folks certainly know a lot about it. Go ahead and introduce yourselves.
My name is Tomasz Jańczuk. I'm the principal development lead working on incubation of server-side JavaScript in Public.
I'm Douglas Crockford of Yahoo, and I discovered that JavaScript has good parts.
I'm Alan Werfsbrock from Mozilla. I'm the editor of the JavaScript standard, the ECMAScript language specification, and I also used to work at Microsoft, so I kind of know about IE9 and what went on there.
And I'm Luke Hoban. I work on the IE team on the JavaScript engine and work with the JavaScript language.
Excellent. So as you can notice, this is the interactive panel. So the reason it's called interactive is my hope is that you'll ask questions. You can ask them at any point in time, unless you want to interrupt someone. But if you have a question that comes to mind, jump up and ask it. I mean, that's the idea. So let's start right off. I mean, JavaScript, object-oriented, dynamic, imperative, functional, misunderstood, as you say. Let's talk a little bit about that.
Yeah, I think it is still the world's most misunderstood programming.
Why? What do you mean?
Well, there are a lot of things to it. One is it doesn't look like the language that it is. It's C-style syntax causes most people to think that it's a simple imperative language when it's actually much deeper. The name is ultra confusing because it really has nothing to do with Java. It's not Java's stupid little brother. It's a completely different language, in my view, a superior language. Netscape and Sun intentionally misrepresented what the language was when it was introduced, although it wasn't possible for them to accurately represent what it was because Raymond didn't tell them. So they had no idea that it was scheme inside. So all of that is causes for its misunderstanding.
Excellent. So let's jump right into the object-oriented side of it. Was prototype-based object orientation the right idea?
Well, it's a different idea from what most people are used to for object orientation. Most people are used to class-based object-oriented languages, and in the early days of object orientation, there was actually a great debate between the class people and the prototype people about which was better or which was more powerful, and ultimately the theorists figured out that they were equivalently powerful, and it was so mostly a matter of preference. And so the fact that JavaScript is a prototype-based language doesn't make it a worse language or an inferior language or a less powerful language. It's simply a different language, and it's something that people have to get used to in coming to JavaScript, is that it's not class-based inheritance, it's prototypical inheritance.
I think it makes it a better language. And some evidence of that is that you can write in a classical style in JavaScript, whereas writing in a prototypal style in Java is virtually impossible. Mm-hmm. So there's much more expressive power there.
Yeah, the one thing that's really missing, though, that I think some people run into is classes can be used as an organizational construct within class-based program. It's a way to organize your code, to say this is the code that makes up a particular abstraction you're trying to define. And JavaScript doesn't have a single syntactic unit that does that, and so you find that in some cases when people write code, that the bits of code that go together to define one concept get scattered around different places. I mean, there is syntax, or it is constructs in the language that can be used to bring stuff together, but there isn't one single construct like a class declaration.
I think that really generalizes. The JavaScript language itself has a lot of these small, very flexible building blocks that allow you to build interesting and complex sort of object hierarchies and that sort of thing. But because it doesn't have the sort of next layer up of features like the classes as realized in things like C# and Java, you're more flexible. You can use that flexibility to do different designs, and that can sometimes be good, but can also sometimes mean that everyone who goes and tries to do something does it in a slightly different way. So there are trade-offs there.
At the same time, I think the prototypical nature of object orientation in JavaScript is probably one of the reasons that language is misunderstood, especially for someone who approaches that language for the first time from C++ or Java background.
Interesting. But what does it get you? You really haven't said that yet. I mean, what do prototypes get you? It's different, but you mentioned, Doug, that you think it's a better model, but why do you think that? I mean, what does it get you?
Because of the possibility of greater simplicity. So in my view, the biggest drawback of the classical model is that it requires that you do classification, that you have to do a taxonomy of a complex system, usually at a stage before you fully understand it. You have to identify what all the objects are going to be and what their relationships are going to be so that you can figure out how to construct it. And it's almost always the case that because you're doing it before you have an understanding of it, you'll get the classification wrong. And the taxonomy will either be incorrect or at least suboptimal. And that requires at some later stage that you do expensive refactoring in order to do that correction. Whereas in the prototypal model, you don't do that classification, so that refactoring never becomes necessary.
So the fundamental thing with prototypical languages that most people who use them, I think certainly in JavaScript today, don't even approach it this way, but the fundamental concept with a prototype is you sit down and you first define one prototypical object, an object that's characteristic of what you want to do. If it's a person, you know, if you're defining the abstraction of a person, you sit down and you define a particular person. You give it a name and you put in a real concrete name, and you put in if then you have an address, you put in a real concrete address. You put in all these concrete details, and then you, through prototypical inheritance, you make variations to represent other individuals. So you're working from an initial concrete value and then generalizing from that. Class-based design, you're kind of supposed to sit down and think about the whole category. What's in it? What are all the degrees of variation up front, and figure that all out, and then you instantiate the individual. So that's the difference in kind of the thought process that's behind the two approaches. But I don't know how often people programming in JavaScript actually think about it that way. I mean, more often my sense is they sit down and say, okay, I need to have a prototype, and it's going to have a bunch of methods in it, so I'm going to pluck down these methods, and then I'm going to have my constructor, and I'm going to instantiate the instances, and they're thinking about it in a very class-like way, even though they're working with prototypes.
Sure, so definitely one of the downsides of JavaScript and the prototypal model in general is that it requires more discipline on the part of the programmer. And given the characteristics of the user community that are using JavaScript, sometimes that discipline's lacking, and then you definitely do see the problems that you're describing.
Probably the other interesting aspect of inheritance is that JavaScript is predominantly used in the browser today. And given the size of the JavaScript code that is written for a typical application, people don't tend to build extremely complex inheritance hierarchies. I think the design issues that we mentioned are probably relevant mostly to framework designers.
Yeah, but that's changing, because as people build complex client-side applications, as they're starting to do, and arguably, for example, any app where you're doing complex construction on a canvas, essentially doing your own rendering and such, you need to start building abstraction models in your code to represent the thing that is your rendering, and that naturally leads to more complex hierarchies and stuff. So I think what you're observing is, that's true, that it has been a characteristic of JavaScript, but over the next 5 years, I think we're going to see that completely change. And I think we're going to see people in JavaScript doing all the same sorts of things that they do in C# or in Java or in any full-featured programming language.
I think that's exactly what we hope will happen.
Yeah. I think that's absolutely true, and there's a bunch of different sort of factors that are causing that to happen. I mean, one is like Canvas is an aspect of it, but the platform itself is getting a lot richer and gaining lots of capabilities, and that allows people to build larger, more application-like applications using that web stack. But also, JavaScript engines have just gotten incredibly much faster. Over the last 5 to 10 years, they've gotten about 100 times faster, which is an amazing, amazing increase. And with that kind of increase, every time we've seen that in the computing industry, that a runtime technology gets that much faster, we see enormous change in the kind of applications that get built and the size and scale of applications on those platforms. And I think we're just starting to feel the impact in this now and for the next couple of years, where the kind of applications we're building, people can rely on having these browsers that have the fast JavaScript engines. And so I think that's going to be a big shift we're going to see in the coming years in terms of what people can expect.
So since this is a mini TC39 committee meeting, why don't you add classes to the language? When you think, I mean, if you're saying you're going to end up programming in a way that you're used to programming today in a language that has classes, why stick with prototypes?
So we are exploring in TC39 various abstraction capabilities, adding them to the languages, ways to make object literals richer, and there are proposals even to add class-like declaration constructs and stuff. But there's a lot of controversy about those. Everybody has an idea of something to add to a language. The real art of language design is deciding what not to add and how you preserve the basic characteristic and sort of the fundamental nature of a language. So,
so removing prototypes is not an option, because that would break everything. Adding a secondary class system might be interesting. We know for certain that there are bad ways to do it. In ES4, for example, we saw an illustration of that. I'm not convinced that we've seen a right way to do it yet. I'd be reluctant to do it until we do.
We have our first question.
I wanted to react on a broader adaptation of JavaScript, not only for the web, but for everything you do with C# at this point. Google's V8 engine has done a lot for that by you can take it and do whatever you want with it. Is Microsoft going to at least open the JavaScript engine in EA to use in other applications?
So I guess I'll give it to Mark in a second, but I think we'll see. We don't have any concrete plans in the near term, but I think it's natural to expect that in the future we'll have some way of reusing that engine. Either Microsoft will start reusing it in other contexts where these kind of things are interesting, or we'll make that a component that can be reused more generally. So I think definitely we agree that the JavaScript engine is going to need more homes than just the browser. The exact mechanics of how that's going to happen, I unfortunately can't speak to right now, but I'm sure something's going to change in that space.
And certainly the Mozilla JavaScript engine is, it's open source, so if someone wants to take that and host it somewhere else, and it's of comparable performance to these engines. But yeah, in general, I think you're right. We're going to be seeing JavaScript engines in a wider variety of situations. It's interesting why that is. I think a lot of it is simply driven by the familiarity of it from the browser, and so people want to use that language in other environments.
No.
Great question. Thank you. So since we're on the topic of changes, adding, addition, do we need eval in the language? Can you just get rid of it?
I would really like to get rid of it. It is, without question, the most misused feature of the language.
Absolutely.
But that we did not get rid of it in ES5, and I think it's doubtful that we'll get rid of it in the next edition.
So eval is one of these very fundamental things that if you actually need to do something, one of the unique things that can only be done using it, it's the only way to do it. And so taking it away precludes certain things that in certain circumstances are worthwhile doing. But it's also the sort of feature that I sometimes call an attractive nuisance. It's a feature that simply because it's there, people use it even though they don't really need it. And sort of all programming languages have features of that. One of the features that's is a very likely candidate for the next edition of the standard is a modularity feature, and that feature may include a way to load constructed modules, so a module that a program actually built itself, and you can look at that as a somewhat different take on eval, and it may be that if we do things right in the standards process, that would end up giving us a more controlled, a more hygienic eval than what we currently have.
So in some sense, the global object would be not touchable through one of these modules. Z-val, you can change the global state, which is, of course, kind of a bummer if that's not your intention.
Right. So the module, if it comes into the language in the next edition, will be the most important thing that we do. It'll finally give us modularity in the language, which is something that we're very much lacking. And at that point, I think it becomes a professional language.
Right on. So go ahead.
Yeah, again.
Please.
AdSafe, for example, is doing things to make sure that third parties can't access any of the global variables and, well, all those things. Is there anything we can do to disallow third parties that aren't compliant using that standard to just keep away from my document.cookie or?
Right. Unfortunately, no. So, since almost coincident with the invention of JavaScript was the invention of the cross-site scripting attack. Yeah. And there are lots of causes for it because all complex problems have multiple causes. One of them is the goofiness of HTML and the surprising ease of inserting wicked code into it, so that script can get onto your page that you didn't intend to be on your page and can be active, and it gets all the rights that the page has. And there's nothing that we can do in the design of ECMAScript to mitigate that. That's W3C's fault, and they need to fix it. And we have tried to meet with them in order to convince them of the urgency of correcting this problem, and we've been unable to convince them of the necessity of such a meeting.
Okay. And C#, for example, you can define different domains in where your code can run. And your code shouldn't even be aware. You just say, all right, I got some code and I want to eval this, but on another domain. And I say, right, you can't access that.
I think in the browser, all script goes into a common global space, so there's nothing we can do with the language to prevent that.
You got a little control when using third-party advertising. You can say, well, render it here or render it there. It's not completely XSS.
We need to do that, and we cannot do it at the language level. We need to do it someplace else.
Even in C#, for example, that's not obviously done at the language level. That's done deep in the runtime and the framework on which it's built. And in the web space, that all is the equivalent of the host, and that's the browser environment, which is primarily specified outside separately from the language. And so, yeah, I think it's a problem that needs to get tackled and is being tackled by various sort of third-party things, but it'd be great to have more work on that. I think the place it touches JavaScript is in things like, we've done with strict mode and potentially how that's going to evolve.
Yeah. Excellent. We got a question over here.
As language designers, what is your opinion of things like CoffeeScript and this kind of layer on top of JavaScript?
Yeah, I love CoffeeScript. I think it's really, really cute. It's a very elegant syntax, has exactly the same semantics as JavaScript, but it is much more expressive, in my view, much more readable. I would be very happy if we could somehow eventually shed our C heritage and adopt something that looked more like CoffeeScript.
I sort of have a slightly different perspective. I think there's two ways that these languages which compile down to JavaScript are interesting. One is as sources of language design ideas that ultimately make their way into JavaScript. I think on syntax, for instance, JavaScript has a certain syntax. I think changing that radically is probably not going to happen. Maybe some small things, but languages compiling down to JavaScript, I think, are going to be an interesting part of the sort of ecosystem of web development. And I think it's great to have a sort of marketplace of ideas of languages and language design going on that can work with the platform. All those languages have a pretty major disadvantage, which is that they have to have a compile step involved, and they don't get to be the actual language that's running there. Debugging tools, those kind of things, you're always going to have this separation. But I think still we're seeing a lot of folks who want the benefits of programming in those languages are enough to justify it. I think there's sort of two classes of those languages as well. There's the ones that take some existing language, like either C# or Java or something like that, and compile it down to JavaScript. And I think those are really important. They bring developers from various languages, give them a tool that they're very familiar with, and help them to get something on the JavaScript platform. But there's always an impedance mismatch there because they bring a lot of their platform sort of heritage with them. They bring either, in the case of C#, they bring some BCL kind of isms and some .NET isms along with the language itself. I think the other category, the languages that are really targeted at being web development languages like CoffeeScript and that have JavaScript semantics and just kind of either change syntax or grow some new features on top of that, I think those ones are actually going to be really interesting because they're the ones that really can long-term feel like really integrated with the platform. So I'm excited to see what gets done in that space.
One interesting benefit also of using some languages higher up than JavaScript, compiled down to JavaScript, is that they may provide an opportunity to actually implement and enforce a profile of JavaScript that allows certain non-functional benefits to be realized at the level of the execution engine for JavaScript. Let's say by avoiding a certain constructs in a JavaScript program, you can afford to improve performance of executing the compiled JavaScript.
Excellent. Go for it.
Just carrying on with that, I'd like to hear from the other two panelists on that same question.
Okay.
So, so I have sort of mixed feelings on this topic. First of all, there is actually a proposal from Brendan Eich, who's the original designer of JavaScript, to the Standards Committee to consider an alternative syntax that's more CoffeeScript-like, and so that is something that has been talked about. Whether that's really important or not, I'm not sure. When you're evolving a language, there's a certain budget of changes that you can accommodate at any point in time. There's actual design work that's involved. There's only so many new features that implementers will willingly digest over a reasonable period of time, and it's really important with JavaScript that all the browser implementers digest the features pretty much at the same time so that the browsers move forward pretty much sync with each other. And if you put a lot of energy in syntactic features like that will tend to take energy away from features that may be providing new fundamental semantics, like, for example, modularity and such. And so you get trade-offs among these. And so, is it slightly improving the syntax? Is it worth it? I'm not so sure. It's,
who thinks it's worth it? Not too many. All right.
What do you think, Doug?
I think it is worth it. It's where we live. And I see people get really emotional about syntax.
Okay, so
and to Alan's point, if we spend in committee all of our time messing with syntax, then we won't have time to do things which might turn out to be ultimately more destructive.
On that point, I think syntax itself can actually be fairly destructive in the sense of kind of bifurcating the user community in important ways, so that one set of users learning JavaScript learns the new syntax, and one set learns the old syntax, and they don't speak each other's language, even though they're supposedly the same language. And syntax can be one of the biggest ways you can cause languages to sort of fragment. Adding fundamentally enabling features into a language typically doesn't cause bifurcation. If people need those features, they go and use them. If they don't use them. But changing things like syntax can have a potentially really negative impact if done in too gratuitous of ways.
Excellent. Got another question over here?
Sort of along the same lines, I'm curious what you guys think about automatic semicolon insertion, and if there's maybe a chance of that being removed or turned off in a strict mode in the future.
Yeah, so we were not able to get it into strict mode in ES5. The browser makers complained that it would be a hardship on them to have to do that in a mode. I don't think we believed that, but we let them win that one. One of the reasons why I'd like to consider redesigning the syntax is I'd like to come up with a semicolon-free syntax, not one that tries to correct semicolon mistakes, but simply makes semicolons unnecessary. I think that would help us to achieve the original goal of making it a better language for beginners, which is still a goal that we hold, although we sometimes lose sight of that. But it's hard to say if we're ever going to get there.
Just to stay on that topic, it would be interesting to go down just a little bit in the panel, and then we'll get to your question. It was designed for simple modification of web pages. It was designed in a couple of weeks, and it was designed for non-programmers. Yet, if you look at who actually uses it, you have the whole spectrum.
We got everybody.
So that's an interesting story. Why?
Because he got enough of the simple stuff right, and he got lambdas in it. And lambdas were enough to hold the scientists. They can do amazing things with lambdas. The beginners didn't need to know about the lambdas in order to do their rollovers. So somehow he managed to satisfy those two extremes, which is an amazing accomplishment in a language design.
Excellent. Alan, what do you think about that?
Well, no, it's true. I mean, it has, Brendan, in designing the language, got the real fundamental concepts right, and then kind of threw on the syntax. And I think, like Doug alluded to earlier, a lot of it was just business politics at the time. It had to look like Java and various other things that caused the syntax to end up being that way, plus pressures about that it wasn't really thought of as a real programming language. It was like a forms validation language is really what it was, I think, the original purpose. But it has this solid foundation of a real programming language, and it ended up being the only real programming language in the browser, in all browsers. And so, since it's there, it's the language we're all going to use.
And I think that point, is one of the really strong things. I mean, I think the fact that the JavaScript language did have these core components which were very flexible and enabling was a sort of a requirement, but it wasn't enough to have propelled it to where it's gotten to now. I think the fact that it was the only choice in this platform, and this platform itself became very popular for many different reasons, has been a really important factor. JavaScript, if it had been designed differently, could easily have held that platform's growth back in a significant way. I think its flexibility enabled lots of the libraries and things that were built as layers of abstraction that allowed developers to do really interesting things with the platform that weren't really thought of at the time that JavaScript was initially developed.
And lest we forget, JavaScript was the second of two languages in the browser. The first one was Java, and it failed. The Java community doesn't like to remember that, but Java was the first at bat in the browser, and it failed hard.
Interesting.
Question. What do you see with the future of out-of-browser JavaScript, like Node.js and other server-side JavaScript implementations?
So this is a very interesting question. So Node.js, how many people are aware of Node.js? Pretty much everybody. So what we are seeing lately is a lot of new developments in JavaScript going beyond just the browser, which is a traditional application. Node.js is probably the primary example, and I think we are going to see more and more of that trend for a couple of reasons. First of all, JavaScript is the most ubiquitous language today. The developer community is probably the largest among all other languages. So that's one. So there is that aspect of developer experience that already exists that environments like Node.js attempt to embrace. The second one is that JavaScript is you can make that statement about any other scripting language, but JavaScript in particular is vastly simpler than some other procedural languages that exist. And therefore, it yields itself much better for server-side applications, where achieving isolation between executing processes is an important factor. Coming back to the question asked previously, there was that analogy of application domains in CLR. This is pretty much the level of isolation you can operate with in the CLR language space. In case of JavaScript, that granularity is actually much, much smaller. So one interesting implication of that is that you can achieve much higher application density on a single machine. So you can run code owned by many customers and prevent that code from actually sandbox that code adequately such that it won't affect the operation of the code running uploaded by other customers. So that aspect is particularly important given the other trend in the industry right now, which is cloud computing.
So could other technologies like Node.js and anything else that's being developed help drive the language in into ECMAScript 6 or beyond?
You know, I don't think these applications really help drive the language itself. They really try to embrace what's already there.
Well, I think they, you know, in some sense have been doing something to drive the language. You know, modularity, which is a feature that we've been talking about, is something that may come in the future. Node.js, for instance, uses that heavily at the core of its experience and uses the CommonJS model for doing modularity, and that's influenced a lot of the thinking in how to do modularity in a future ECMAScript spec. So I think, you know, having new places where JavaScript is being used is clearly going to be an influence. I think it's just going to be one of the many influences, but I think it's a data point and it's something that matters. So.
Yeah, and I mean, one of the things a language needs to evolve is it needs experimentation. Language designers may think they have a solution, but until you actually implement it, people try to use it, you're never quite sure. And it's hard to implement inside of browsers for browser manufacturers to, you know, just make up some features and throw it in the browser and ship the browser. But if you have lots of...
Mozilla does that all the time.
Well, Mozilla does it on occasion, but most of the other browser vendors don't, right?
They're more careful.
They're more careful, that's right. So if you have alternative places where the language is being used that have less global impact and stuff, I think there's more opportunities for experimentation with the language.
I think one other point on this idea of you know, server-side JavaScript and generally JavaScript outside of the browser is, in answering a previous point, we sort of had to say, oh, a certain thing is outside of the purview of the JavaScript language, right? Which can be a bad thing at sometimes, but one of the good aspects of that is that the JavaScript language itself is actually a very well-defined, isolated component, which has no fundamental dependencies on the web browser, has no fundamental dependencies on its runtime environment. It's actually very, very easy to sort of go and put in different environments. And Node.js has done a good job of leveraging that and on top of V8. As we mentioned earlier, I think there's going to be more of this kind of thing happening in the future.
Interesting, which kind of brings to the point of if you did have a higher level abstracted language that, say, incorporated the DOM, and then implemented on top of JavaScript, that would, because that's one of the things, you know, the DOM and JavaScript, it's one of the things that's, let's talk about that, Douglas.
Right, so most of the people who use JavaScript, who hate JavaScript, and there are a lot of those people, I used to be one of those people, actually hate the DOM. They think they're hating the language, but it's the DOM that they're hating, and for good reason, because the DOM is a hateful thing. It is difficult to use, it's at the wrong level of abstraction, it doesn't modularize at all, its components are poorly selected, it has extremely poor portability. It's awful from almost every vantage point. But you can take any Ajax library, and there are maybe hundreds of them now. I mean, there's a vast number. And they're all compact. They're a small amount of JavaScript, which is layered on top of one of the world's worst APIs, which transform it into something that's pleasant and productive, which is amazing. You know, it's another piece of evidence of the power of JavaScript, that it can do that. It has that much transformative power. So ultimately, I would like to see us throw the DOM out and replace it with something that looks like an Ajax library, because they do it right. You know, it should be something that looks like jQuery or like YUI or like Dojo or one of them. They're all good. I don't really care which one of them wins this. We should have a beauty contest and pick one. But we should do it with an eye on security and improving modularity and some of the other problems that we're suffering from.
Interesting. What do you think about that, Alan?
Well, yeah, so there's truly two aspects of this. One of which Doug was mostly addressing, was the actual design of the DOM interfaces themselves. And like he says, yeah, it's not a good interface design. It's not a good object-oriented design. It's just not a very good design. And hopefully that, I mean, you can imagine how in the browser there could be a replacement for that. If and how it will happen, I'm not sure. The other aspect of it, though, is how is the DOM implemented? So traditionally in browsers, part of the reason the DOM was the way it was the DOM was implemented in C++, and it was really a direct mapping of these C++ objects translated into JavaScript with an interoperability layer between them. and such. And there were things that those C++ objects could do in their implementation that you couldn't do in JavaScript and stuff. And in the development of ES5 and looking at the next revision of the standard, one of the things we've been looking at is making sure that the JavaScript language itself is expressive enough that the things that you would need to do to implement the DOM, even given its current ugly interface, you could do in JavaScript. And the performance of JavaScript engines is such that you can imagine that you don't really need C++ to build the DOM. And so, for example, one of the things we're working on at Mozilla is prototyping just doing the DOM entirely in JavaScript, right? And then you suddenly have a much more flexible implementation where, in fact, you can experiment with alternative interfaces and such.
Interesting. But I mean, eventually you're going to have to talk to C++ if, say, you're running on a... Well, I mean, JavaScript's not going to be implemented down at the machine layer.
Eventually you have to talk to GPU.
Interesting. But I don't know. Bashing C++, man. I don't know about that. Go ahead.
We should be bashing C++.
Why?
It's terrible. That's why.
This is not a C++ panel.
Well, speaking of languages, it seems like over the past several years there's been a drastic increase in the number of languages that have been coming out, for example, Ruby and things like that. Additionally, there's been an upsurge in some of the older languages like Lisp, re-emerging. So a lot of changes in languages. I was wondering if any features you particularly liked that you would think might be interesting to go into JavaScript in the future, particularly any that you don't agree on between the people up there.
I'm not in favor of transforming JavaScript too much. I'm very much in favor of looking closely at other languages for their own sake and of designing new languages. And I'm very happy to be living in an age where new languages are getting traction. I love Scala, I love Clojure. There are a lot of things that are Erlang, a lot of things that are great. I remember a time when it was C or Pascal and that was it, or an earlier time when it was Fortran or BASIC and that was it. So right now we've got
COBOL, but
yeah. How could I forget COBOL? So today we've got much more choices everywhere except the browser, where there's just the one choice. And that's unfortunate. I wish we could work out the security model in the browser so that we could have other languages. That would take some of the pressure off of JavaScript to try to be a universal language, because I don't believe in universal languages, so I think that's a dead end. One of the main things preventing us from doing that is the security model in the browser. That JavaScript, for its obvious security failings, is actually closer to being a secure programming language than everything else that we're considering. And so until we get smarter about how we do security, JavaScript is about all we can stand.
Well, on the other side, I think there is huge value in JavaScript being the language for the browser, because that really helps drive some momentum around the improvements and the investments that the different vendors in the marketplace are putting into, let's say, improving performance of the engines. Right? So at the end of the day, I think the average user of the browser, who doesn't really care what language is being used under the hood, benefits.
Luke? In terms of, the question was about kind of features from other languages that might be attractive in JavaScript, and I generally agree with what Doug was saying, that I don't think we want to just go randomly choose a bunch of features from other languages. But one feature that I have seen in other languages that I think is really would have actually more value in JavaScript than in most of the languages that have it is a feature similar to C#5's async, which is a way to basically do asynchronous programming very simply using just straight line code that looks like it's synchronous code. And this is so important in JavaScript, where all of your code is this async, callback driven programming style. But that programming style, although JavaScript developers are very familiar with it, can get quite cumbersome syntactically and can make your code substantially harder to read and reason about. And so I think it's a place where we could really bring in a fairly small feature that might have a big impact on the ability to write and read sort of callback-based code in JavaScript.
Awesome. What do you think about that, Doug, about adding async, and also Alan, of course, and Tomic? What do you guys think? Let's go down the line, talk about that. What do you think about adding an async
Well, it depends on what you mean by async.
Well, like the C# async,
You know,
as I just explained.
Right, I understand. So in general, the JavaScript language design community is not enthusiastic at all about multi-threading. I mean, I don't think anybody wants to add shared state multi-threaded asynchronous processing to JavaScript. But event-driven processing is the way the browser is programmed and such. And so there are various ways that improved support might be added for that. There could be syntactic constructs to make it better to do event-driven programming. Dave Herman has designed a library built upon iterators and generators, which is one feature that's being considered for the next iteration of JavaScript, which provides a pretty nice model to handle asynchronous tasks of that sort. It's not unlike what's going on in C#, but it's done as a library. The only language feature it requires is the support for this generator abstraction. So, so in general, yeah, improving support for the things that people are already doing, I think that's a good idea.
Great.
Yeah, so I'm not sure we need new syntax for this, although if it turns out to be expressive, I think we can solve the problem in the language as it currently exists. You know, there's a paper on arrows from the University of Maryland, which is a really interesting way of doing composition, which could make callback construction easier. There's RxJS from Microsoft, which is brilliant, more an event-style thing doing the same thing, which I really like, very composable. There's Judge Schmidt's Fab, which is completely undocumented but totally amazing, where he's got all these functions which take functions as arguments which return functions, and he just strings all these invocations together. An amazingly weird, twisted style of programming, but very powerful, which avoid Luke's problems. I'm doing some stuff with requesters, which take callbacks and encapsulate them in functions, which can also be composed in parallel or in sequence. So ultimately, I don't know which of these patterns, or maybe other patterns, will prevail. But before we go and start tacking new language features on, I want to see if we can use the language as is.
Interesting. Tomek, do you have any comments on it?
Well, I think the developer community is already very much used to the callback-based programming model. And this is something that definitely works. Having said that, I have seen what the await keyword has done to async programming syntax in C#. And I think there is huge value in simplifying the syntax itself as long as an underlying model for asynchronicity remains unchanged.
Limit the twistedness. So let's go to questions.
Kind of a follow-up to that. One of the nice things about JavaScript and the fact that it lives inside of this sandbox and has this kind of limited set of features is it requires kind of a different mindset when it comes to programming. And I'm sure some of the creators of JavaScript never thought that you'd end up with stuff like jQuery or some of these other, really cool abstractions on top of JavaScript. I'm just wondering what your thoughts are about the benefits of this constraint, of being inside this set of constraints and what it does for, innovation from a programming level.
Yeah, the main thing about those constraints are the security that we get from it. So one of the reasons why I think web applications became important was because people became distrustful of all other kinds of applications. Because if you install something in the desktop, it gets way too much power and can get very destructive, whereas there are constraints on how evil something can get in a web browser. JavaScript's, or the browser security model is way inadequate, but it is still better than every other application delivery system, including everything that came after it. So for some reason, nobody was able to learn the lessons of the browser model and keep repeating the mistakes of the desktop. The limited power that JavaScript gets has been a blessing so far. I think that's why it has become such an important language.
Yeah, and that's really not even so much a language issue. It's really a platform issue. The most widely used platforms, the operating systems, came from a time where the way applications were run was any application was given all possible privileges and stuff, and that was simply the way the systems were built. And it's only really with the browser that people started thinking of a really constrained environment. And today, I think, for new platforms as people build them, and particularly you see this in the mobile space, but I think it really applies universally. Now platform designers realize that you don't start with universal privileges, that you start with a mechanism where every application is going to be sandboxed to a greater or lesser degree, and more often than not to a greater degree.
Yeah, and once we get rid of the global object in JavaScript, which I hope we can do in the next edition, then we've got this, you were suggesting this, in JavaScript, every object, every function is essentially its own sandbox. It's a capability system, and so we get extremely fine-grained security out of this thing, so that if any object is compromised, that doesn't mean the whole application is compromised, it's just that one object. And the capability that an attacker can get from compromising that one object is probably going to be very limited. That's an amazing thing.
The very interesting property of JavaScript is that there is very little you can do with the JavaScript language itself to do harmful things. The worst thing you can do is probably allocate some memory or run an infinite loop to consume CPU. But the key question is really, in a given scenario, what is the library support? What are the added APIs on a given platform? And these are different in the browser, obviously, and in other applications like Node.js. So given that JavaScript really provides a clean slate security-wise in all the other scenarios, we can go about designing the sandbox in a way that is appropriate for the scenarios that only materialize today, like cloud computing being one of them, for example.
Yeah, question? Oh, you have another?
Oh, it just made me think of a comment I wanted to make, was that I think a big change you're going to see is a lot more focus on building libraries and building class libraries, if you will. The last time around, the wheel of reincarnation of dynamic languages and such, really a major focus was on object modeling. How do you figure out what the objects are that go into your system? How do they relate to each other? How do you build large complexes of objects to model complex problems in your program? And I think as we see people moving from building simple forms validation and type apps in JavaScript to actually building full rich applications, we're going to go back to this age of thinking about what are the objects that make up my system? How do they relate to each other? How do I figure out which methods, which responsibilities are assigned to them? And so I think, in a year or two, that's going to be what we're talking about, is how do you actually design your complex JavaScript applications?
Excellent. Sir?
Going back to the async issue, I was just curious if any of you had looked at the Apollo project and Stratified JS, had any opinions on that, or have you ever heard of it?
Can you talk into the mic?
Yeah, what was the project?
Apollo and Stratified JS.
Apollo and Stratified JS?
Yeah, it's basically a common JS module implementation that as it imports your module, it rewrites the JavaScript, and it basically adds async await type support to the language. It adds a couple of new keywords, but it rewrites your JavaScript as it imports it so that it's standard ES3 compatible JavaScript. I was just curious if you had, I guess you haven't ever heard of that, so I wanted to know what your opinion on something like that would be. It's basically a 30K runtime.
30K?
It's like 30K that rewrites, just rewrites JavaScript to have more features around async programming. So.
I haven't looked at that particular project. I think it kind of falls into the category we were talking about earlier of, I think this category of languages that start with JavaScript grow a little bit, like async features, like whatever the things are that we might agree were useful, or a certain set of users might think are really useful things, that those are going to be interesting. And I think it sounds like a very useful tool. I just haven't used it myself.
Go for it.
When we were talking about the fixes that had to be done to the browser, Like these whole security model, you said much of the stuff is actually a job of the W3C and not your job. But I'm pretty sure you do have opinions about what should be done by the W3C. So can you talk about what actually they should do to fix up this stuff?
Yeah, so my biggest disappointment with HTML5 was that they added a lot of really powerful new capabilities like local storage and local database and sockets and all that stuff without first securing the programming model. Because of their failure to attend to security first, it means your cross-site scripting hazards have now gotten significantly worse because your attacker gets access to all of this stuff. So what harm can he cause to you and your customers if they can get at your local store? And they did nothing to prevent that. And I'm outraged at that. I think that was criminally irresponsible.
So is that true?
It is true.
Yeah, and I think another issue is that there are many web APIs being designed, and they generally aren't being designed by JavaScript programmers. They're being designed by C++ programmers, and they tend to look like C++ interfaces. And you go back to the whole reason of why is the DOM interfaces so ugly. It was because, well, they're basically C++ interfaces that you have to access from JavaScript. And that's still going on. As these new functional areas come into the browser, the experts in those areas who are defining the features, in many cases, aren't JavaScript programmers. And in fact, the W3C's approach to design still is largely that the browser is a language-neutral platform and that APIs should be designed to support any possible language, when in reality there's only one.
And it's not the one they want.
And it's not the one that people are designing for.
Interesting.
It's about what should they do. I mean, that's what they did and shouldn't have done.
Well, they should design first for JavaScript.
Yeah, and I think they should be working closely with ECMA because the JavaScript experts are there. That's why ECMA and W3C need to be working together. It's ridiculous for them not to be working together.
Makes sense. So how general purpose is JavaScript? I mean, in some sense, we've been talking about that. All the questions that have been asked generally point back to that. In the browser, outside of the browser, in the cloud. You can't write an operating system in it, and you can't do things as powerful as C++ or C.
Well, it depends. It's Turing complete, so in theory you could.
But in practice, it doesn't happen.
Practically, you wouldn't want to.
So how general purpose is it?
It's very general.
It's very good. Yeah.
It's an application language.
Yeah.
So the main difference between a language like JavaScript, sorry, I've even tripped up on it, a language like JavaScript and a lower level language like C++ is that there's an extra level of abstraction between the hardware and the language.
Yes.
And it's that extra level of abstraction that makes it difficult to use JavaScript to do something like write a device driver or something where you need to twiddle bits in the hardware or get very close to the hardware. It's not impossible, but it's probably less efficient, and that's why you probably wouldn't use JavaScript to write the kernel of your operating system, or at least the device drivers. But once you get above that level where you have to have some close mapping to the hardware, it's a general purpose language, and you can express pretty much anything you want in it.
A good example in that space is also the design of Node.js modules. There is very little that is done actually at the native level. Most of the implementation is already done as a JavaScript code. So it's just a testimony to how much you can get done in JavaScript itself.
So, I mean, are we seeing in the real world any other usage patterns outside of the browser and on a web server with Node.js? I mean, in some sense, we're not seeing the theory realized as you've expressed it. So my question is, are there places where we're seeing it? I mean, I don't know if people out there have seen areas where the language is being used to build applications outside of the context of a browser. Clearly, you need to have a runtime to write in it, but you understand what I'm saying?
What?
So
I think in a sense, I expect we're going to see that. I think there's some things that have changed recently that make that more likely. One is that, as noted, the sort of previous generation of JavaScript runtimes weren't as easily extracted from the browser. V8 has shown with Node.js that it can be extracted and put in a different host, and I think we're going to see an increasing trend in that direction. And also the performance of the engines has increased enormously, which makes it a more attractive scripting language than potentially other scripting languages you may choose, which don't have currently as performant of runtimes. And so that may be a better choice for many sort of scripted hosting environments in the coming years, now that we do have those faster engines.
Well, let me just argue with you. Even the term scripting language is probably an inappropriate
Yeah.
term. The kind of the history of that term is almost as a way to describe a limited use language or a not fully general purpose language that's useful for limited uses of tying things together. And JavaScript has gone way beyond that, and it's really just a general purpose programming language.
Yeah, I meant that only in the sense of being hosted in other environments and being used as the sort of hosted language for programming against some other object model that isn't the DOM, but is maybe being plugged into an application as the sort of application development language, or into a game, or into an operating system, or whatever.
So maybe it's time to change the name of it, because it isn't Java and it isn't script, and the name is completely wrong.
Absolutely.
Weblang.
Change the name.
Weblang.
The name won't change the functionality. So what do you think, Tomek? And then
I think there are more and more interesting applications of JavaScript going beyond the browsers. Node.js is just probably the single most prominent example, but Google, for example, is already using JavaScript on the server to drive little scriptlets or pieces of program that can tie the variety of their applications online. It is used as a backend for implementing extra functions for Google spreadsheets. So this kind of almost used in the context of an expression language. So I think we are going to see more and more applications of JavaScript where previously there had been another language used. People want to combine the simplicity that comes with JavaScript as a language with its power that goes beyond the previously used solutions.
Yeah, it's in the best databases now. So it's in CouchDB, it's in MongoDB, it's in applications, it's in almost all of the Adobe suite. So you can use JavaScript to manipulate Photoshop and Illustrator. It's in operating systems, so you can write desktop widgets in Windows and in Macintosh. It's in TV sets. Yahoo's got a thing where you can do Yahoo widgets in TV sets.
Oh no.
Yeah, it sounds kind of general purpose to me.
One really way of looking at JavaScript is that this is the most ubiquitous language, in the sense that probably most computers in the world have a way of running JavaScript. If you have a browser on a machine, it can run JavaScript.
And
that's one way of looking at it.
To follow up on that, and we're getting close in time, is I have to say here to everybody in the room, if you don't know how to program in JavaScript, it's time to learn, because over the next 10 years, believe me, you're going to have to do some JavaScript programming.
I would have said if you don't know how to program in JavaScript, join the club.
Well, that too. You want to learn how to do it well.
Well, that brings up an interesting point, because you talked about before that it's a language actually that's very, very productive without having to learn about it. So most people probably don't realize they're programming in a functional way. They probably don't understand that they're using closures when they have functions, nested functions. So can you talk a little bit about, that's really an excellent point.
Yeah, the language has so much expressive power that you can get a lot done not knowing what you're doing. And that's sometimes a criticism of the language, because people are using it without knowing what they're doing. And that's a fair criticism. My advice is know what you're doing. It pays off.
Buy Doug's book.
I think it's great that there's actually this spectrum that that you can get in and use it really immediately and be productive without having to go and read a book. But then if you do start building larger and larger applications, you can learn the whole language very very easily. You read Doug's book, and then you have a tool that is a very, very expressive thing if you do kind of treat it as the programming language that it really is.
Excellent. So let's go down the line. We have a few seconds left, and the biggest problem that's on your mind about the language, or as you see the future, just go ahead and give us 10, 15 seconds of what you think about the future for the language, the biggest problem that concerns you, whatever something interesting,
I
dramatic.
think the biggest threat that I perceive behind JavaScript is doing something with the language that will bifurcate the developer community. Because I think the biggest benefit behind JavaScript right now is that there is such a huge developer community that programs against a single language. And as much as we have seen breadth technologies in the past kind of taking over the industry, and a good example is HTTP, which was designed for the web, and it has applications today that goes well beyond the web. I think we are going to see the same with JavaScript. And the biggest threat to that, I think, is trying to bifurcate the language in any way.
Yeah, there's a lot of pressure on the language to get more complicated. I would rather see it get more simple, mainly because I'm concerned about the security of the language, and simplicity is easier to reason about than complexity.
Yeah, I really already gave my message. It really is that JavaScript is the ubiquitous programming language for the next 20 years of computing, and get on board.
And I think I would say, similarly to Alan, I'd say something kind of more on the positive side. I think I'm really excited to see, we've recently just gone through a phase where now every one of the major browsers out there has both a fast JavaScript engine and a JavaScript engine that has the new set of ECMAScript 5 features, and also has a breadth of this HTML5 support. I'm just really excited to see what people end up going and building. I don't think we can even imagine the kind of things that we've unlocked with this set of 3 sort of improvements we've made over the last few years.
Yep. Excellent. Well, hey, thank you guys for doing this, and thank you for